Introduce you Mr. Uberto Barbini, who will present the next lecture.
Hello. Yeah. My name is Uberto, and I will talk about a topic that I'm really passionate about. And okay, first, just two words. My Twitter handle is Ramtop, and you may have know about Ramtop because it's present in the Pratchett novels, but also when you were working on ZX Spectrum, for the less young of you, maybe, it was at the top of the RAM, the memory. So if you have to write something, for example, in assembler, some subroutine for your game in assembler, the first thing that you have to do is lower the top of the RAM and having a bit of a memory where to put your program. That was how programming was at that time. But okay, the topic of today is about the legacy application. And I don't know how is widespread, but in at least in London, it's called a brownfield development, when someone proposes you to work on a project that is not a brand new greenfield project, but it's something that you have to pick up from all the stuff that was already there. And everybody is, so it's very hard to find people to work in brownfields development. And even when you work on that, you just try to fix the minimum possible things. You don't want to touch too much, because there could be other problems that you have no really clue. And this seems like a kind of necessary evil, but not a good thing to work with. But in Japan, when I was in Japan last time, I got this inspiration. And in Japan, they have this idea of basically instead of having throwing it waste when some cup or some precious hairstone got break, instead of throwing it away or trying to fix, they, in a kind of invisible way that is never invisible, they make the fix so interesting that is a part of the object, fashion of the object itself. And I mean, it's nothing that we really want to do in software, but it's something that kind of got me an idea. And the idea is that this is absolutely not a scientific graph, but the idea is that you can choose which line to follow. So you can have a project where basically for each feature that you add, you have a higher cost and delay. Or you can try to follow the blue line and have a kind of standard, stable way of increasing time with the feature. And it's a choice. It's a decision that you can make. And if you really, there are two difficulties. I mean, it can be difficult, but it can be done. And what is mostly needed is the will to do that, and having a different way to look at your legacy project. So first, let's see what are the legacy project typical problems. And yeah, obsolete technology, they don't scale, we have new requirement, it's very hard to change, it's expensive to run and maintain because there is really no love in there. Another way to see it is a kind of a technical debt default. We are so full of technical debt that we really give up and say, okay, whatever, we don't really care anymore. And typically also there is a working overload. So it was a system that was perfectly fine when we have to move 10 boxes, but now we have to move 1,000 boxes, and the system is really not able to cope anymore. And also we have this kind of temporary fix that at that time seems such a great idea and smart solution, but they are not really very good to keep. And at the end, it's always a continuous state of emergency. We have to run every time there is something to do, and we really have no time to plan anything. And then we cannot even retire it because we really don't know who is using it. In a big corporation, there could be some piece of software that nobody really have the courage to retire because it could be that it is critical for some project that maybe just got triggered once a year to do the final year assessment, and if it's not present, everything will crash, and we really don't know. So what is the usual solution to all this problem that we have? Yeah, let's rewrite from scratch. Let's make it shiny and new, and let's forget all these bad things. And if you have seen Moana, like my daughter, I've so many times, but you can also imagine the song. But is new always better? Well, it's not that because we have a nuclear weapon, we don't use fireworks. And another risk for the rewrite is that every time there is a kind of rewrite, everybody kind of jump in and say, okay, since we are going to rewrite, we'll have a new requirement or another few new requirements. And so the idea of something shiny and new that will be solve all our problems instead of a lot of hidden cost. And we have also this success bias. So when we have something that is working, we always assume that it was pretty easy to do because it works. So I mean, someone else did, so it must be not so difficult. And we didn't know the history of the current process. So when someone wanted to rewrite, it's always very easy to say, okay, rewriting something that is working now is very easy because we just have to copy. But usually it's not that the case. And also, there is a lot of knowledge in the current code, and many things that we thought they are kind of bugs. Actually, they are not bugs. They are actually requirements that everybody forgot about the code, and they are actually needed. So if you remove that, then you have a problem in production. And then all these new feature, the one that everybody wanted to add, that make the project really, really take longer because everybody wanted to have, it's just a small feature, can you also add this, can you squeeze in, something like that. And still, all during this time, the project is still running and is still critical for the business. It's actually making money, and but there is no resources because all the resources are in the new project now. So the old project is really short of hands, and if there are any problems on the old project, probably they are just fixing the possible quick, dirty solution. And then at the end, we also forget about always data migration. Data migration is always more painful than everybody was expecting. And when you have a new system, you have really to plan about data migration. So there is an actual risk that you can get in a kind of distressing position where you have something old that is really obsolete and nobody really knows because probably you also fired the people who wrote, and who knows, some people that maintaining without knowing very well. And we have a new system that is not working yet. And so, I mean, I've been in that kind of position many times. And also when we do this kind of operation, operation, we easily forget that there is some details that can be quite dangerous. And there was a reason that piece of wood was in that position. So what's happened more often that anybody is willing to admit is that the big new brand rewrite is left unfinished, and someone is still picking up the old application. And also another typical issue is that we need just another adapter. I say, yeah, we can also add this one. We can also add this one. At the end, our kind of new, shiny application is just a bunch of adapter on the older stuff, and it's not really shiny. And comparing to the effort, it's really not so worth. So what I'm going to produce now, to discuss now, is having a different approach. And also, doing the work for this conference, I found this quote that is exactly what I was thinking, but said much better than. And so that Brian Strostrup, that I hope you know, said that legacy code often differ from its suggested alternatives by actually working and scaling. Because legacy code is always something that it's working and it's making money, it's making business. So it's always something that we have to respect. So the idea that I have is instead of big rewrite or throwing away, plan your safe route. So if you want to go to one solution to another solution, the easiest way will be just okay, let's rewrite better with the new Java, or it could be much more complicated, like we have a SQL, C++ application. We wanted to move to NoSQL, big data, Java application. We want to have a monolithic C# application. I mean, there are so many things. But the idea is that instead of just rewrite, try to make it with split the root with several milestones, and be able to deliver, to make in a way that you deliver each milestone every few weeks. And each milestone may have to stay for a while, so each milestone must be a solid solution itself. And so what I mean safer, it sometimes doesn't mean straight. So it can be that in order to do that, you have to do kind of a convoluted way, but at least you are sure that you go on the other side. So as a kind of a small thought exercise, we can think about this kind of problems. And we can split a monolithic Java backend to microservice in different language, for example. And to do that, we have the monolithic application. We can think, okay, let's try to every 2 weeks to split out a service of that application and replace everything that is using that functionality to call to an external service that is providing the functionality. And then it could be making 2 weeks, it could be making more than 2 weeks, but we can split more grainly, more finely, one function at a time. And then this should be able to, in 1 year, 2 years, I don't know how, it depends on the application, to provide a new solution. We can switch from another application that runs on client server to REST backend and having some JavaScript running. And then in that case, we probably wanted to take the old application, put a new REST API, REST access point to the old application, and having the JavaScript contacting that application. And then slowly move the backend from that application to an external service that maybe is using NoSQL. And in this way, we can kind of plan the whole route from the current state to the state that we want. And in the worst case that we don't have a resource anymore because there could be many business reasons for that, we still have a solution that is probably not optimal, but is still a good step in the good direction, in the direction we want to go. And now a bit of a technical part. Once we have the root, we want really to change the code, how to introduce this code with a bigger code base. And mainly, I mean, I did this kind of things a lot of time in the last 10 years. And sometimes the size of application was some several million lines of code. And in several million lines of code, there was like 20 unit tests. So good luck with that. And you cannot really, okay, let's refactor it all, because it will take just 1 year to refactor in a way that it can be tested, and then you have to change. So what I found instead useful is to start writing external acceptance test that really test the application end-to-end. End-to-end, not in the meaning of the whole application, but in the meaning of from outside to input to output, whatever the input to output are. And you at least you cover all your test cases, and ideally more than that. But at least you have something that is better than nothing that was before. Then you try to split the application in modules. And then you don't need to clean everything at the same time. But if you wanted to work in a new module, you just need to clean that part that you are going to work with. And it can be that, for example, you make a new module for something that you don't want to work with. So something that you wanted to mark in your test and working on something that is calling that new module. Or it can be that you wanted to work in the new module. So in that case, you're working on something that you are sure that is not touching all the rest. And then you can repeat as many times as necessary. If there is no business reason and you are happy after a few modules, you can leave it like that. If you want to go till the end, until you have a completely clean application, you can also do that. And okay, I call this method alchemical refactoring. And the reason was that I was reading this book. That is a fantastic reading if you like a bit of history, philosophy, and chemic. And there's basically this idea of alchemy was something that was like humble mumbo astrological stuff. But at the beginning, in the Middle Age, alchemy was really like a bleeding edge science. And they were doing incredibly sophisticated chemical experiment. And their idea was not completely stupid, like we can say, because the idea was that they had this kind of theory where gold was a very pure metal, and the other metal was a kind of impurities that from the perfect metal. So they said if we take iron and then we polish and we remove all the impurities, that will become gold. Okay, of course, it's not like that, we know. But it was a kind of a scientific theory, and they were trying to experiment. And in that experiment, they found a lot of other new chemical elements, and it was very interesting. Well, this is only to say that I was reading that book when I realized that I have this problem. So I kind of see a kind of similarity between the alchemic search for gold and my search of refactoring old application. Okay, I call chemical refactoring, but technically speaking, it's not a refactoring, it's a rejuvenation of code, which will be because we can introduce some small changes of behavior. I mean, refactoring should be completely 100% exactly the same behavior than before. If we kind of to rejuvenate the code, there will be some, for example, we fix some bugs if we found the bugs in the meanwhile. We probably don't want to have a null pointer and got thrown it away, so we wanted to raise exception before rather than wait. So there could be some, this is just a note. So it's a rejuvenation actually, but it's not such a catchy name. So to do that, the first step actually before even start is make it easy to work with. So first thing, you probably wanted to have some kind of Docker image or virtual machine or stuff like that that is possible to work on your legacy project in a reasonable time. Because another characteristic of legacy project that's the setup time is really like, I mean, days, if not weeks, and probably there is not even, you have to ask this guy that knows how to set up the variable that you need to connect the password and stuff like that. If at least you have a kind of Docker image or virtual machine or very clear wiki how to set up this stuff, you can embark on new people in a few hours instead of weeks. And this is, I think, step 0 if you wanted to have and it's definitely worth the effort. Then when the first step of this process will be to wrap this test end to end. And you really wanted to put the two ends as far as possible, so to be sure that you are really testing the whole system, because in this phase doing unit tests really doesn't help much, because there is so many things that you don't know yet about this project that you cannot really do unit testing. You have to try to keep the whole production system as a black box. And then once you have this kind of test, you can try to touch the code for the first time. And being a legacy system, that means that probably there was no automatic test before. So doing the first test itself is actually giving a value to the business. It's not something that, okay, before touching the code, we have to spend 1 month doing tests. It's completely waste of time. No, that month is actually very, very good value for the business, because for the first time, they have a system that they can test before going in production. And in my experience, this is quite typical. If you already have a acceptance test for that project, that's fantastic. You can skip the first test, of course, but usually this is not the case. Once you have that, you can start looking at, it's still too early to touch unit test to do some actual refactoring, because there is so many things that you don't know about. So you have to try to split in modules. And what I mean, like cut vertically, not horizontally, that you don't want to have a modules like database, UI, model, or persistence. You wanted to cut the modules vertically. So it could be login, can be a module that has its own UI, model, and persistence. You can have the inner calculation. You can have as many, depends on your domain, as many vertical modules that you need. And now with also Java 9 modules, it can actually help you a bit on this stuff, because make modules like a first level object in Java. And once we have a split module, we have some modules, then we can start a refactoring. We have this big spaghetti code, and we can really, really enjoy ourselves, and throw it away and make it. After the end of this, hopefully everything will be tidy and tested and ready to use. So we can just start with another module and go to the mess again. And this is more or less the idea. And I call this kind of splitting the modules. I call it like hermetical modules, because you want this module to be hermetical. And also the English word hermetical came from the alchemy, because the container of for doing the alchemy was something related to Hermes, the god. And it must be really sealed, so they created this word. It was the first time that someone needed a real hermetical container. And the second time, this is how to refactor the spaghetti code. I will show some example. I call solver in coagula, which was another hermetical word. Just. Okay, so let's go directly to the code. The typical anti-pattern, I don't know if you know the names, but you have seen this before. That are typical in legacy code are stovepipes. That means you have several flows that are almost identical with just a copy and paste and few variation, but they are replicated many times. The lava flow is another code type where basically your code base moves slowly from one thing to another and leave a kind of trail of half forgotten, half never used code, but it's not completely dead that someone is still using. And because at some point someone thought that it was nice to use, I don't know, XML configuration. Then someone came up and said, no, YAML is better, so let's remove XML, switch to YAML. But not everything, just 90% of them. So we have still 10% of XML left. And then someone decided to use Spring, and then they say, no, Juice is better, so let's remove Spring and move Juice. Yeah, but there's still another 10% of Spring sprinkle around. This is lava flow. And spaghetti is when you have a bunch of classes that everything is talking with everything, and you really don't know where to look at, because it's so entangled that anything that you touch has a dependency on anything else. The code class is another typical thing that you have a class with many thousand of lines of code that trying to do everything itself. And then there are the intrusive framework that they also can create problems itself. Okay, before going to my code, this is a very good book in talking about legacy code, how to work effectively, and this is another very good book about how to work with the legacy code. What I think this kind of book missed, not that it's a defect, but is that they are very technical and very analytical on many specific solutions, and they are very, very good on that. But they are kind of missing the big picture. And they are also both a bit older, so they don't know, they don't speak about the new kind of solution that are available. So I kind of found this a couple of techniques that I wanted to present today. So one is to split the modules. The idea is you wanted to wrap the code using a kind of facade, the design patterns. And it's not a normal facade, because usually you want to use the facade for a design reason. In this case, we want only to use the facade to remove the code, to cut the dependency. And at the end of the day, it could also be that we wanted to remove that facade again. But for the moment, we need it. And remember that, this time when we are writing this kind of code, we usually don't have a unit test. So doing a refactoring without unit test is always a very delicate operation. But if you have a acceptance test in the world of things, it can be still be done kind of safely. But you have to be very, very careful on not doing any, introducing any change in the behavior of your code. So to show you some code, because there is a bit of technical stuff on this talk as well. This is almost real code from production. I a bit polish it and remove a reference to clear, but was more or less it's more or less real code in production. And the idea that there was something that was basically pricing some financial instrument. So you get a connection to a database, to a data store. Then it fetches some content that is related to the market of this financial product. Then it gets basically the portfolio of trades of some client. Then you get some configuration, because according to the client and the context, you need to use different options, basically, when you do the calculation. And at the end, you do the calculation, which is a kind of a pure function that only given this parameter give always the same result. This is kind of clean. And at the end, you wanted to put the response together with the context, so you can see, okay, from this context, I got this result. Now, the problem is that, okay, we wanted to remove connection and options, because we wanted to change our code, but the code behind the connection behind getting the option from the option store, it's really complicated, and we don't really want to touch. So this is the setup. So our first step basically is to create an interface that give us this the connection and the option. And then we kind of create a new module that is, let's call a data context, that we have this data context builder. New module is a terrible name, but it's here only for you to know. And the difference basically is not much a difference. The only thing that the previous calls, first there was this helper class. Also, don't call anything helper. It's really not helping much. Helping manager are really terrible names, but this is how code is like. That was a fetching up a connection and configuration. Basically got kind of hidden behind the new modules. So it doesn't seem a bigger change, but we are already using this get data context. And then from the get data context, that is this new interface that we don't know about the implementation here. We get all the connection, get option, and get context. So this is already something better. But we still, inside the run calculation, we still use a connection, context, and option. So we want also to remove that. So we can see that inside this run calculation, which is technically a lot of code, we use the option basically to calculate the portfolio and to get this X. So what we can do is, since option apart, they are owned by this new module, instead of giving a back option, we put this with method. Basically, instead of the interface has an option, get option, instead of exposing option, we expose the method that it will be use option. And then we do the same with the connection. So in the portfolio, basically what we use, we apply some transformation to the connection, to the portfolio before doing the calculation. And we do basically the same things. We apply the calculation and we hide the connection. So this data context doesn't have a connection anymore. It has a context, but the context is immutable value, so it's not a problem. Of course, this is working. I'm not saying that is perfect. It works for this example, so of course everybody have to find its own example. And this run calculation method, before we have these 4 parameters, this is just a simplification. The actual method is like 20 parameters, but let's keep it simple. And the new one just this data context. And data context knows how to use the transformation and the calculation. So basically, we move everything to the new method. And now the new X is also much simpler because we just get the new module and do the calculation and return the new result. And if there are other places in our code that use a connection and option, we can do the same. At the end, when we commit this in Git, it also should be quite easy to see because we can see that we don't touch the old code. When you see the Git report before the commit, you can see if you're touching the old code or not. And so this is it's not a new refactoring, but it's a kind of new way to use several refactoring together. So once we have that more or less step done, we have a small module. And when we have that small module, we can use actually unit test. We can start a unit test in that. So let's assume we already did the unit test. So now we have still a bunch of classes that do a lot of things together, and it's very hard to disentangle. So I have found this other fancy name. Solver coagula is another alchemical operation, and we wanted to basically to disentangle all these classes where it's absolutely not clear which are the responsibility. And so the idea, this is pretty simple. This is a small code that basically giving some address, and the client will will output this nice label. That's very incredibly smart code. And but if you look at the code base, you can see that there is address is pointing to client, client is pointing to address. label is pointing to address, to printer, printer is pointing to, there is a lot of dependency. This is absolutely typical. Actually, it's quite much more simpler than the real example that I'm sure you have in your code, but just for see. So the idea here is pretty simple. All the methods that are not just a getter, basically, we wanted to make it static. So we created this classic function, and we copy all the methods from all the classes in here. And of course, when we move some method like getLines, this is internal method, so we have to make it, we have to add address as a parameter, so the self class. This is pretty much automatic. IntelliJ can also do with the simple refactoring. Just make a method static in moving the internal object as a parameter. And when we have done this, it's pretty easy to understand, because if we have just one parameter, okay, then it's clear this method should be in this class. But when there are also, if one parameter is a string, it's clear that we are not going to add the method to the string class, so this method must be to printer. But for the other two, we can see that we have an address and a printer. Here we have a client and a printer. And it can be both way, I mean, and make it very easy to see here what we want to do. We can make the printer know about the client, or make the client know about the printer. And one thing that we can also see is that actually, probably a client should know about the address, but an address shouldn't know about the client. So we really don't need this method to be public, because it can be a kind of internal to the client. And I found easier to say that, okay, client no printer, rather than say printer no client. But it really depends on your project and your decision. This is just a method it's just a tool. So when we have the kind of coagula part, we put all together. So we move all the function from the class to the actual classes. And in some cases, we can also leave the method as a static inside the class. I mean, there is nothing wrong with that. And so this is how we'll be at the end. And so we have a client. The client gets an address as a parameter. We have a printer. And then we say we have this label print that get a printer and a client. So actually, my solution was that client shouldn't know about printer, need printer to client, but having a static method. But you can do whatever you want. I mean, it's a client decision. But having everything static in a single class make quite easy to see. And anyway, if you want to play a bit, all this stuff is on my GitHub page. So all the code that there is a bit more code. And if I find more code in the future, I will also add. So legacy can be good. It's only a matter of will and love. Very quickly, how to prevent things to go in legacy. One problem is the slow boiling frog. You know that someone said that if you, I never tried, but if you put a frog in cold water and then you raise the temperature very slowly, the frog cannot jump, because when you really want to jump, it's already too hot to have the strength to jump. And it's the same with the legacy code. Code started to degrade slowly, and then there's also this idea of broken windows. When you have everything is clean, nobody wanted to break any windows, but as soon as a windows got broken, it's very easy to break all the other windows, because nobody really cares. So it really go down. And to try to avoid that, the idea is to have this Kaizen, which is a typical concept of lean methodology. That means basically you have to keep trying to make things better, even to leave things at the same level than before. And the other idea is to plan the whole cycle of your application. So if you want in the future, for sure you wanted to retire your application. So from the beginning, you should try to keep who is using, how is using, and why is using. So, and the final point is that you should really have a kind of a good architecture. Usually the software architecture is someone that drop some boxes and arrows documents and left everything to the. But software architecture should be much more than that, and should be based on this kind of Vitruvius idea. But probably this will be another talk in the future. Okay, I leave this is my blog and Twitter if you wanted to contact me later if you have a problem, or I mean I also do consulting job, so if you have a problem you can hire me. But any question? Everything was so clean, or maybe completely understood? Okay.
So thank you very much for your lecture. And the last one will start in 15 minutes.